So what I want to talk to you all about now is actually do half live, half not live demo. So the first bit is not live, so that'll go well, fingers crossed, and then the non-live bit we'll see. I watched Spinal Tap the other day, and I'm hoping it won't go that badly. So what I'm going to show is actually building up a microservices infrastructure from scratch. So I've got some kind of cloud, and I'm going to talk through how I can do that using Cisco Mantle. I'm then going to show just deploying a very simple web app, nothing complicated, talk through a little bit about the architecture and what makes it a web app. And then we're going to go live, and I'm going to try and, well, you'll see. So with that said, and for those of you that went to my session over in the other room, you will have seen me make this ask. So please do, if you have a favorite superhero, or even if you don't have a favorite superhero, if you wouldn't mind just going here and voting for one. This is just a stupid little web app. The source code is on GitHub, so you can have a look at the source code if you don't trust me. It's just look for My Hero. Put Cisco in there as well. So this is just a silly little web app that we started off actually years ago when we created some cloudy stuff in Cisco. We created a MySQL and PHP-based application to do this. And that's an awful way to demonstrate modern applications, right? PHP and MySQL. So we migrated it to be a containerized microservices app, and it's got all kinds of bindings into things like Amazon Echo. We can use instant messaging to vote. But for the purposes of today, I'm just going to use the web interface. And really the idea is I just want to get a little bit of data in there because we can show then what it's like as we go forward. So please do vote for your favorite superhero. Unfortunately, Captain Cloud is not one of the options. I didn't include him, which I should have done because he's awesome. So again, for those of you that were in my talk earlier, you'd have seen me put something like this on. Is this familiar to all of you, what a typical container stack might look like? Where I've got some kind of cloud here at the bottom. I've got provisioning, resource management, scheduling, orchestration, service discovery, load balancing, and then some very upset administrators on the top who've got to manage all of this crap. And to put some logos on it, then typically when we actually deploy this live, then in our case, this is what I want to talk about. So we've got OpenStack running in the bottom. So everyone familiar with OpenStack? Know what it is, know what it does? Anyone here love it? One of you? I love it as well. So OpenStack running in the bottom, and this is actually Cisco's opinionated version of OpenStack, something called Metacloud. I'm then using Terraform and Ansible to set all of this up, so I've got a whole load of Terraform and Ansible scripts and plugins and so on to run. I'll demonstrate some of this as we go through, not in super technical detail, so if you want the super technical detail, yell. Mesos, Docker, Kronos, Kubernetes, Marathon, Console, and Traffic. Everyone familiar with all of those and could write a white paper on them? Good, right. I'll see you later. So the point that I'm trying to make with this container, with this on-premise container stack is, this is a lot of work for somebody to do, and it's traditionally not something most of the operators I work with can do. They can't set this up. They don't have the skills with a lot of the organizations I work with. And so it typically falls to people with more, I guess, ninja skills, and they're wasting their time having to manage all of this. And so I want to just talk about how easily this can all be set up and show a demonstration of that working. And this is something called Cisco Mantle. So what about the easy way? What about the easy way of getting this done? So this is Cisco Mantle. So I'm going to actually just run through a non-live, but kind of looks live demo. So the code here, everything I'm showing is on GitHub. You can see the link there. So it's Cisco Cloud, and then there's just a Mantle repository in there. And what Mantle is going to do is it's going to set up that entire container stack for me on any cloud. So I've had this working in AWS. I've had this working in Google Compute Engine. I've had it working on vSphere. I've had it even working on my laptop using Vagrant. But I'm actually going to show this working on Metacloud, our OpenStack offering. So I go ahead and just clone in the repository. And this is how easy it is to start setting up all of this stuff. So the first thing that you have to do when you build a container stack like this is you have to worry about certificates. Who enjoys doing certificates on OpenSSL? One hand. You enjoy certificates on OpenSSL. Okay. Most people I know don't enjoy certificates and OpenSSL because it's a lot of work to get something that you feel should just kind of work out the box. So this will take care of generating your self-signed certificates. If you want to put in your own CSR, then you can put that in there and it will deal with that as well. So I'm going to get my certificates. I put in my administrator passwords. I'm not going to tell you what that is because I know some of you are keen exploiters. I then create a config file. Now, just for the purposes of the demo, I didn't want to type a config file out by scratch because it's a lot of, a lot of time for me just deleting stuff and so on. But I thought I'd show you them. So here's my OpenStack configuration file. So to build that entire stack, this is all the config I need. And there's a template that comes out of the box. So really all I'm doing is I'm just saying, hey, use this private key, this SSH key, because we need one of those. Use this... build me this many servers, so build me this many Kubernetes servers. In fact, I've disabled Kubernetes for this particular demo. I'm just going to use Mesos and Marathon. Build me this many controllers, this many workers, this many edge load balancers, use this network and use this floating IP pool. And that's pretty much it. That's all I need to be able to do to build that entire stack. And then I can just hand it over to Terraform to take care of the rest. The next thing that I'll need to configure is just my Ansible YAML file here. Again, super simple stuff. In fact, I don't really configure anything here. The only thing I'm putting in is just the domain name that I want to do. So we've got this stupid website called mrsmiggins.net that we use for most of our demos. And so everything here is just going to be deployed onto that domain. And I'm just using Cloudflare to do that. So in my configuration, I didn't show this in the configuration file because I didn't want you all to see my Cloudflare token for the same reasons that I don't want you to see my password. But as part of this configuration, I'm going to set up all of the domain stuff as well. So I take care of domains, DNS, I take care of setting up servers and setting up the applications. So simple little config. And then I kick it off. Oh, well, I also need to get my OpenStack credentials in, my MetaCloud credentials. But then once I've done that, it's just a case of Terraform get, Terraform plan, Terraform apply. And here I go. And in the amount of time it's taken me to sort of talk about this, I have, or I will, set up an entire container stack. And I'm going to show you what that looks like. So while this is building actually in the demo, why don't we go and take a look at it. So this is Mantle. And you can see from one page, I have everything I need as an operations manager to look after my container stack. So I can access any part of it. So let's say I want to have a look at how my resources are doing. So I want to go ahead here and have a look in Mesos here, which is my resource manager, to see what the heck is going on. Well, I was a bit worried there. It's just Mesos. And that Mesos is integrated perfectly into Marathon for me then to have an orchestrator that can then call the underlying resource manager for everything to work. Totally out of the box, a single web page for me to go to, all deployed in about half an hour, 45 minutes, with minimal config. And so as the demo runs through, you can see here I'm just pinging all the Ansible stuff, and I'm now just deploying it. So I upgrade all my packages, and literally, here we go. Here's my playbook. Now, I have sped this up. So this is where I've cheated in the demo, because typically this whole thing will take, I'm not running Z-Shell here, but if I was running Z-Shell, it would tell me, I think it takes about 40 minutes to run. But if you consider how long that would normally take, and the fact that you wouldn't have support, you wouldn't have the opinionated versions, I've got to take care of all of my certificates and passwords and building all the stuff, all the individual components and so on. Not to mention, I've got to go out to each individual cloud. So I've only done OpenStack here, but maybe if I wanted to do OpenStack for maybe test and development, and maybe I wanted to use, I don't know, AWS for production, well, that's then two whole sets of things I've got to go and configure in two sets of environments. Using Mantle again, I have the exact same look, feel, and smell, regardless of what underlying infrastructure I'm running it on. So let me show you what Cisco MetaCloud looks like. And if I call it Metapod, shoot me, because that's what it used to be called. So let's have a look at what Cisco MetaCloud looks like. So it's just OpenStack. So this is my underlying infrastructure that I've now deployed this onto. So just so I have my Mantle instances here, and everything is nice and up and running, just like you'd expect it to in a stable OpenStack environment. Now, one of the really neat things, one of the things that slightly sets Metacloud apart from typical OpenStack is not only that it has a 4 nines SLA, so a guaranteed chance of it working, but also for any of these individual nodes. So let's take one of the control nodes here. I get all kinds of graphs and stats, and I can see things like my network usage, which is not really setting the world on fire, my disk ops, and of course my CPU utilization, and I'm hitting that CPU hard. And I can see that at a glance for anything. So that's one of the neat little things from an operator's perspective about Metacloud that I don't get out of the box with default OpenStack Horizon. Well, let's go back to the demo. I'm just going to fast forward that bit there. And just to show as well that all of your standard OpenStack commands work as well with Metacloud, so I can see all of my Mantle instances here. I can see the IP addresses. I'm sure if you pinged them now, you'd get something. Please don't try and destroy them. Okay, so I've talked through how easy it is to build an app, right? And hopefully you can see that actually, build my infrastructure. And hopefully you've seen that with a couple of lines of config, I can deploy my full container stack on any cloud. And it's nice and easy. Doesn't matter if it's VMware, doesn't matter if it's OpenStack, it doesn't matter. From an operator's perspective, I have a nice supported instance, and we call that Mantle. Having that underlying infrastructure, having a load of stuff that can run containers isn't really that exciting. No one is going, wow, this is the best thing I've ever done, because actually what you need is apps. You need apps. And I mentioned earlier that a colleague of ours built a MySQL-based PHP application, and he wanted to use that as a demo here. And that's a terrible thing to demo. So he re-engineered it. And he called it the My Hero application. And this is the thing I've been begging you all to go and vote on. Has anyone voted? Anyone voted for My Hero? Good, quite a few of you. I like that. If you haven't voted yet, the URL's coming up shortly. But the idea is that we have a proper microservices application here. So we have a whole load of different ways for people to access this through Amazon Echo, Spark, which is Cisco's instant messaging client, mobile phone, so you can text to vote in, and of course, your boring old web browser. And all of this code's open source, so go and have a look at it if you're interested. I then have a presentation layer, and this is my web presentation layer if I'm going in through that, or my Spark or whatever. So these are all microservices, and I can scale these up as much as I need, as much as the application needs, and I can put these in different locations if I need to as well. So, and I'll show you how we scale that up. So at the moment, I'm running simply just 3 web servers split over 2 virtual machines. And I can work with my underlying resource manager to take care of that. I then have an application layer in the center here, which is handling all of my logic. So that's what's actually presenting the list in JSON format of all the superheroes that you could or would want to vote for. So that's, in this case, I've only got the one application layer because it scales very nicely. And as always in the case of these kind of services, why write your own when you can just steal other people's code? So we have a nice little load balancer proxy on top of each one, which is traffic in this case. And then finally, I've just got a nice little MongoDB layer at the bottom that's doing a NoSQL database storing all of your votes. So again, I'm not done really anything for that data layer because the lovely thing about containers is you don't have to. So for those of you not familiar with Docker, the great thing is that you take the work someone else has done, more or less, you add only the thing that you need it to do. So in the case of Python, for example, I take a Python container, I put my scripts on top of it, and it takes care of my environment. It'll even pull down the right packages for me, so I just create a requirements file. It'll put all the right packages in that container and then ship it off. So I focus on the code, not on infrastructure. So this is my very, very simple My Hero application. And to deploy this, it's so easy. So first thing I do is I just pull it down. Pulling down this app is super easy, like everything these days. I've just stuck it on GitHub. I've actually forked this from the guy's demo. I'll send out with our gift bag all of the details of this, or we will. So pull down the code. And the really neat thing here is that actually to run this application, it's as simple as, again, just defining where the stuff that I've configured sits. So where is my control server? What's my username? What's my password? What domain do I want to stick it in? and what I want the application to be called. What I have now is I've got my 3 tiers of my application, got my app, data, and web. And of course, if you're familiar with Marathon and how easy it is to do this kind of scaling stuff, I can click into app, I can scale it up. So if I'm running 3 instances now and I want to scale it up to 5, sure, no problem. Oops, no problem, here you go. Now I've got 5 instances of the application. I've just scaled my app. Pretty easy. And the app can auto-scale, so I can talk to my underlying scheduler to take care of these kind of things, and I can look at, excuse me, the kind of environment that I'm running in. So nice and easy to start doing this. And again, all I've done is I've just typed a couple of lines of CLI, and I've already got this kind of environment. Now I'm just pulling down code from GitHub. So let's deploy that application. So my hero install, and there it goes. It's now deployed. So see how we're doing on the votes. Oh, people like Wolverine. Has someone just voted for Wolverine over and over and over again? Right, okay. So the thing is that I think I can beat that. This isn't a fair election, you see. I'm going to win. Because I really like Star-Lord. Because I like the film Guardians of the Galaxy. And I reckon I can win. So what I'm going to do now is I'm going to show you how I can write a microservices application to attack my microservices application. And I'm going to code it up so you can just see how easy it is to do this stuff, and so that you get an appreciation for how quickly I can do this. Now, when I first did this, they called it, I did it actually when someone else, let me take a pause. I was in a session when someone else showed this demonstration, and I didn't like the way the results were going there. So I decided to do laser nuclear launch from space and attack the application with loads and loads of votes for my favorite one. And that's exactly what I'm going to do now. So let me fast forward this. Okay, so this is how easy it is to start attacking an application. So the first thing I need to do is create some kind of repository and some kind of Python script. And this is all mostly in real time, so I'm just going to write a very, very simple Python application. For those of you not familiar with programming, don't worry, I'm going to step through it. It's super easy, nothing complicated in here at all. So all I'm saying is, right, let's fast forward this a little bit. So I've got some code there. I've got to do this quick, you see, because I'm worried that someone with a laptop can beat me. So I've got to win, you see. So all I'm doing is, this is a fairly gentle approach. So I have created a little function here that goes off and just votes. So it votes for whatever hero I send as an argument there. So in my case, I'm going to say, right, go and vote for Star-Lord. I've then just created a couple of threads. So a thread is, in an operating system, is a way of running a process in parallel. So I'm running 4, or in fact 5 threads in this particular version. So 5 threads there just to continually vote for that hero, because it's in a loop. So 5 threads, continually voting. Now, if I ran this on my laptop, I'd get pretty good performance, right? I'd get a reasonable number of votes, probably a few hundred a second. Because I'd be limited by my bandwidth on my laptop and maybe the number of cores and so on and so forth. So this is just a very simple little Python application that will attack my voting ballot. But you know what? I don't want to run this on my laptop. Why do it when I can scale it out as a web service? So let's create a Docker file and put this in a container. Let's containerize this. For those of you not familiar with Docker, again, super, super easy. I simply say, hey, use the Python library to create this container, fire off my particular script, which is vote.py, and vote for Star-Lord, not Wolverine. Okay. So I created my Docker file. Now the last thing I need to just build that Docker image and throw it up onto Docker Hub, which again takes a few seconds. It's pretty easy to do all of this stuff. You just need an account on Docker. So pushing out my container now to Docker Hub. And there we go. I now have the container up there. So the last thing to do is just write a microservice definition. So this is all I need to write to create that single-threaded evil application. Or kind application, depends how you mean. I've recorded all of this in real time. I just didn't want to be fat-fingering Vim as you were all watching because I'd have got super nervous. Let's fast forward this a little bit. So you can see all I've done, I've just got a nice little definition here that says, by default, spin up 5 instances of my horrible voting application. They don't really need a lot of CPU. They don't need an awful lot of memory. Just give them 32 meg each. That should be fine. One thing just to be aware of, if you're doing these kind of microservices applications, be generous with memory. Because by default, if you use, say, one of Amazon's CentOS images, for example, they really do dial down, dial up the nice value. So as soon as you hit 32 meg, it's going to kill the process, and it's going to kill your container. It's the #1 source of problems that I see when I talk to developers about their containers dying. It's because they don't give them enough resources into something like Mesos to handle. Anyway, so 0.01 CPU, 32 meg of RAM. And rather than show that, let's just see how the results are going. Oh, goodness. Seen a bit of a change here. 393 votes for Wolverine from 297. Someone is super keen on the Wolverine. OK, so let's deploy the application. Let's see what happens when I nuke this from space. So load up my Mantle credentials. I have to do this because I don't want to show you guys the password. And I'll go into my hero voter folder. So I've just created a very simple cloud deployment script. Nothing clever. All it's doing is just using a curl command there just to basically fire in my config file. Again, I've stuck all of this code up on GitHub. You can have access to it. You can analyze it. There's nothing exciting about this particularly. So let's deploy it. And there we go. It's deployed. We are now exploiting. And let's have a look in Marathon. Go back to, applications, my hero voter, deploying. Now, I was quite generous out of the box because I just said, 5 instances, that'll be more than enough. But I don't think it is. I think I really want him to win. Let's stop the current deployment and scale. So every thread count, I am now going to be doing 4 times 50, so 200 votes every time, continually, all the time, every time I get a response. Now, I typically can't check the results while this script is running because it absolutely kills the server because I'm only running in a single instance. But let's see what's going on here. So it's still staging. There you go, 49 of them are staged. It's just pulling down the image from Docker, which takes a few seconds. There we go, it's pulled down. So I've got most of them are coming up now. There we go, 50 instances running. So you think Wolverine's still going to be winning? Who thinks Wolverine's still be in front? No one? You really think I can just create an evil application that quickly? Well, let's find out. So I'm going to destroy this first. So I've only run it for, how long did I run that for? A minute? Less than a minute? All right, so killed. Wonderful thing about containers is you can kill them as easy as you can create them. No warnings, nothing, just kill them. Do it through the CLI if you want as well. Someone was saying the other day that Google create and destroy 1 billion containers a week. I don't think I want to try this with 1 billion containers voting. I think might get a bit over, probably might start hitting some integer overflows. Oh, look at that. So just like that, it's so easy to write a scalable web application. And I'm sorry, whoever, 484. Is someone just clicking refresh on their phone? Who is it? Come on, admit it. We've got the Wolverine fan. We've rumbled you. But it's that easy to create and deploy. And in fact, just for that, I'm going to redo a few more Star-Lord votes here. Let's scale him up to 100. When I first did this, I actually did 50 threads, and I actually got blocked by Cisco IT. That's not even a joke. They shut down my DNS entry and blocked port 8080 for the entire of San Jose Building 10. So you have to be careful when you want to start attacking other people's applications. The trick is to distribute it, and that's where containers are great. So if you want to do DDoS, use containers. No. So really what I guess I wanted to show was just how easy it is to set up, to manage the container stack, which you just saw. I had everything I needed in 40 minutes with very minimal configuration on any cloud to deploy this kind of application. I then wanted to show how easy it is to deploy existing applications, which you saw when I deployed the My Hero app. And I can start extending that by adding things like Amazon Echo, which is voice support, and maybe a bit of Lambda in there, which is something that's on the GitHub page. I can add instant messaging support and, of course, web support, which you all used. And then I then showed, and what I wanted to show was how easy it is to take a piece of code that you write on your laptop, in this case just a small little Python script, put it in a container, and then throw it out and scale to the point where you are hitting probably a denial of service on here. It's not looking good on the reload, that's for sure. Let's kill this. But how easy it is to take down a website of your own making. There we go, to get 7,000 votes for Star-Lord. Just to show how easy that is to do. Oops. I definitely don't want you to vote for your favorite superhero at this point. So that was really all I wanted to show you all, is what Cisco is in the cloud game. We're working to make your lives easier. We're putting everything that we do in the open space, in the open source area. All right, okay, well, thank you all for your time. Thank you.